So we're going to look at number 5 from the 2018 free response. And number 5 says, the following histogram summarizes the teaching year for the teachers at 2 high schools, A and B. So it's how many years have you been teaching? Now, this paragraph is pretty important. There's a lot of information here. Teaching year is recorded as an integer, with first year teachers recorded as 1, second year teachers recorded as 2, and so on. Both sets of data have a mean teaching year of 8.2. Okay, so that's mu is 8.2 for both. I'm kind of just going to move those out of here for a second. And it says, with data recorded from 200 teachers at school A and 221 at school B. Now it says, on the histograms, each interval represents possible integer values from the left endpoint, not including the right. So from 1 to 4 only includes teachers who have taught 1, 2, or 3 years, not 4. The second interval includes 4, 5, and 6, not 7. And that's going to come back to be pretty important in a second. So part A, the median teaching year for one of the schools is 6 and for the other is 7. Identify which school has each median and justify your answer. So I'm not going to write this out, but I'm going to explain it to you guys. So a couple of things. We know the median is the middle number. So if you have 200 people in survey A, then the median is going to be between number 100 and 101. So so if I take 200, it's going to be 100 here, then the median, then 100 here. Well, what's going to be that median? Well, let's see. 46 people fit between 1 and 3, 48 between 4 and 6, that's 94. That means that number 100 and 101 have to fall in this range, right? Because if you add the 24 here, it's going to be way over that 101th teaching year. So the median for here has to be between either 7, 8, or 9 since it's in this group. So it has to be 7, 8, or 9, so that means the median in A must be 7, which leaves us with 6 for B. Now, if you want to justify that in B as well, let's take a look at the justification there. 221 divided by 2 is 110, so it's going to be about the 111th term. So where is 111? 79 plus 34 is 113, which means that it has to be either 4, 5, or 6. It has to be in this category right here, so that means the median must be 6. Part B, an additional 18 teachers were not included in the data from the 200 at school A, and the mean of those 18 teachers is only 2.5, which is way less than the 8.2 that they told us. What is the mean teaching year for all 218 teachers? So the thing you have to realize, and we've seen this problem before, is that if you have a mean of 8.2, it doesn't matter how you get there. It means that there are going to be 200 teachers that when you multiply by 8.2 and divide by 200, it's going to be 8.2. So we have 200, let's assume that. There are 200 teachers at 8.2 plus 18 teachers that all have 2.5, because that would give you an average of 2.5, over, and now how many total people are there? 218. So this is how we're going to find that new average. And again, think about it. If every teacher had 8.2, then they would have an average of 8.2, and their numerator would be whatever that is. Same for 18 times 2.5. So I'm going to clear out all these equations. Give me a second. All right, so 200 times 8.2 plus 18 times 2.5, and you get this, and take that whole thing and divide it by 218, and that gives me approximately 7.729. And part C says, and part C is a little weird, it says the standard deviation of the teaching year for the 221 teachers at school B is 7.2. So I'm going to just put that up there. Now I'm using population because I'm assuming it's all of the teachers there. If one teacher is selected at random from school B, what is the probability that that teaching year for the selected teacher will remain within one standard deviation of the mean? Now, you might be saying one standard deviation, about approximately 68% or 68.2%, but it's not normally distributed. It's clearly skewed. So instead, what I'm going to do is this. I'm going to think about it like this. What is plus or minus one standard deviation? So if I take 8.2 and I add and subtract 7 8.2, it's going to give me this interval. 8.2 minus 7.2 is 1, 8.2 plus 7.2 is 15.4. So I want to know how many teachers fall within this range within 1 standard deviation. So I'm going to go back up. Well, that means 1 to 15.4. Well, 15.4 means include everyone except the people at 16, because they're really only doing integers here. So good thing is the right number doesn't count. So I'm just going to add up everything here. That's going to tell me how many teachers teach within 1 standard deviation. So we already did 79 and 34. And let's say this one is 28, 29, and 19. So now what we're going to do is we're going to add them up. So we get 79 plus 34 plus 28 plus 29 plus 19. And we're going to divide that by the total number of teachers at the school, which was 221. And we're going to find that out. Let's see, 79 plus 34 plus 19. We're going to take that and we're going to divide it by 221. And there you go, 0.855, let's say. It's about an 85% chance that they'll be within 1 standard deviation.